we come to the last hour of World Biomarkets and the last hour of content that we have in the conference and the last hour of meetings before we can have some nice cold beer and wine. So this is the part of the conference where the speakers really earn their stripes. We're at the end of a busy 2 days. Everyone's tired, but you have got ice lollies, so that should give you a little bit of a sugar hit somewhere, okay? So we've got a fantastic panel, first of all, followed by 3 bio developers that really encapsulate what this event and the community is all about. So, with no further delay, please put your hands together and welcome to the stage Lars Börger from Nova Institute and his panelists.
Okay, so thanks a lot, and great that there are still some people left. Firstly, secondly, this is how a usual workforce will look like after AI has kicked in. So, no, we're gonna learn about this. Yeah, we're going to go into the panel straight away, and I will introduce yourselves just briefly. But first of all, the only lady on the panel is actually Chantal. We called her, right? Chantal GPT. She will help us in the very end and see what we've done. But I just need to start her. I hope it works. Okay, so this is ChatGPT. But now to the humans amongst us. Okay, so great to have you here. I'm going to start by sharing one old story, and this will reveal how old I actually am. I started to study chemistry in 1992, and in the first year of my studies, I was actually listening to a lecture about neural networks. And what was shown there was really interesting. There was some olive oils from Italy, and they were put into a gas chromatograph and some other analytical devices. And the data which came out was put without any further information into a neural network. And what came out was a map of Italy, roughly. So somewhere in this analytical data was obviously hidden some geographical points. That was now some years ago. That's one message. The other message is, at that time, it was only like 50 neurons or something. Now we talk about billions of neurons, so let's see what that does. So with this, I'm turning to Vince. Thank you very much for stepping in, because your Hans was kind of stuck somewhere in Italy, maybe testing olive oils. I don't know. And so, Vince, you will introduce your company and yourself a little bit, but I would give you also one question. So what I talked about is obviously an old concept. So how much of what we are seeing today is just a rebranding, and how do you differentiate between the actual new things and the old things?
Yeah,
Vince.
Thank you, Lars. Well, my name is Vince Hop, and I'm a process engineer consultant in Process Design Center. And our company basically is involved with R&D and steering R&D to develop from small ideas into large commercial plans. So basically, do the complete scale-up to see what we can get out of it with the techno-economic analysis, life cycle analysis, because we want to take care of the environment as well nowadays. And with that, we use our own ProSyn AI system, which has already been more than 30 years old. However, back in those days, it was called an expert system and not an AI system. So basically, the name has been changed a little bit since we go with flow. But also one funny example that I came across a few weeks ago actually was 6 to 8 years ago when I was still doing my master thesis. I came into some statistical equations for my studies and to pass the statistics exam. And I saw in this article that that same equation was now called AI instead of like a statistical equation. So they just basically changed the name because it fits better with the new society. So let's say what AI is basically a lot of times it's a rebranding of some statistical equations that have been around there for more than a few decades at least.
Well, thanks. Let's see and find out if there is it only rebranding or something new quality. But turn to you, Jan Ham. Yeah, probably T&O doesn't need too much of introduction. Still, would be great if you could say what you're doing there. And of course, yeah, well, I understand you go into new polymeric materials. So AI is there. So what keeps you busy? I mean, you should be done, don't you?
Yeah, thanks. So TNO is a Dutch organization for applied research, and there I'm principal consultant in the field of circular carbon. So everything from renewable carbon into fuels and chemicals and materials. And in that domain, I also work with a team of data science experts and polymer experts to try to develop new polymers. And I actually agree with Vince. A lot of AI stuff is not per se rebranded, but it is actually powered by supercomputing power. So I think lots of the principles that we now see applied are already existing for decades, but now we have the computer power to use them. Lars, I think your question deals with what are we waiting for? And I guess with all models, it's garbage in is garbage out. And so we are focusing a lot on the garbage in part of the equation to focus on quality data with which we can train the models. And actually, we still use neural networks to combine structural information of a material with their properties to be able to predict these correlations. So it's, on the one hand, it's focusing on data quality, data generation as well, because there's not so much data on polymers. And at the other hand, we look at the models themselves. So the state-of-the-art models are actually not so sophisticated. They miss all kinds of critical information on polymers, and thus the predictability also suffers, and that's what we are improving. So once that's finished, we get to the product.
Okay, so that means you really need to work on the databases first before you can really then use the new tools.
Yeah.
Thanks. So turning to Damien, your career is impressive. You have been in the biotechnology world for decades, I can say. So the question to you is maybe, okay, how many of these decades could you have saved if AI would have been there already? Or other way to ask it is, how much does it influence the speed of innovation in your surroundings?
Well, g'day everyone, and Lars, I must admit I'm glad we shared a beer last night because I was a little prepared for your stick. It has been a long career in industrial biotechnology. It's a passionate place for me. It's where I was always meant to be. In that time I had commercial leadership roles at Genomatica, at Gevo, in the Dow Chemical Company as well, looking to how we move into this economy in a much more meaningful way. I think what we saw during that period of time, and I was fortunate enough to have my hands in the commercialization of 7 different biotechnologies from idea to market.
Yeah, you tried to sell something to me as well, I remember.
Yeah, that's right. Checks in the mail, yeah. And what we saw during that evolution is the tools were getting better and the timelines were getting faster. Yeah, so we moved beyond capability to accuracy to relevancy, always in the sort of pursuit of the business case has to make sense, because if it doesn't, the investors don't turn up, and we're all looking for the next brave new world to try and improve. I think when I started, it would take years to engineer an organism to proof of concept. We could map the network, but we really didn't understand the constraints. We didn't really understand flux. We moved past those. The reagents got a lot cheaper, orders of magnitude cheaper to work with. Cycle times got better. What used to take a couple of years and 40 people now takes much, much less. In my current role with Exozymes, we engineer enzymes to function free of the cell in a way where we use AI to go beyond the prediction of structure to the prediction of function and activity. That's what we call exozymes, free of the cell with that AI inspiration in there. We did a proof of concept on a product we announced last month. It took us 2 people in 6 weeks. So, things have really changed in speed, which not just opens up lower investment costs against opportunities you want to go and spend money on, but it also opens up the scope of products you can think about as targets to generate solutions for in the future.
Thanks a lot. And also thanks for being very quick, as AI tells us to be. So that's very good. So now the actual question I'm always having is really, does it add a new quality or just a new quantity? So in light of what you have been saying, I'm not sure what is really the right answer to that. So how would you answer that? Is there something in your field where you say this is really something which adds a new quality to innovation? Now we talk about the innovation part first. Or is it only quicker in what we know? Any opinions on that?
Oh, maybe from my end, maybe with AI, quantity equals quality in the end, because you can get rid of so many actual experiments with the quantity of AI. So by simulating all these experiments, you can actually reduce the amount of experiments you need, and I think that's also providing quality as a service. I think I heard an example earlier today where actually predicting toxicity is better than doing the actual animal testing. So I mean, also then quality is improved.
So that is a hint to that is a is it quality or quantity? What is it then? I mean, it's within the same framework, is it?
I think it depends where you are in the journey. Right? I love this answer because yes, that speed is one of the key things that's different for us today. But like in our environment where we're engineering enzymes to become exozymes, we're still trying to maximize the inspiration. So we don't necessarily want to do less work, we want to do a lot more work, but we want to do more work to find better things, yeah? So we don't just want to create an enzyme where we can predict its structure, we want to create an enzyme where we can predict what it does. And that's the quality element, right? We're getting better quality results through the use of AI in these systems. Now, at the early stage, of cost of experiments are pretty cheap. That's not limiting our development journey. So therefore, we want to maximize the number that we can accomplish. But as you get later in the journey, I can see how, well, going into engineering programs become an expensive iterative step. So therefore, maybe what we want to do is cut down the useless experiments and really just focus on the important ones.
Exactly.
Okay. So Winston, you and the experts, you said more or less a rebranding of an expert system which was there.
Yeah.
Is there a chance to get out of the frame which the experts have fed into?
Well, in our case, our AI system is not really like what you see nowadays with the ChatGPT kind of things or with the neural network, for example. But we have more like a framework kind of base. So we have set some rules based on thermodynamical principles, physical properties of chemicals and stuff like that. And it goes through a question and answer kind of setting. So basically, a colleague of mine made this analogy, and he refers to going to the doctor. So you're going to the hospital or something like that, there's something wrong with you, because otherwise you wouldn't be there. And first question the doctor will ask you, what's wrong, generally? And you give an answer, and then based on your answer, the doctor is going to diverge into which region could the problem be. And that's also what our expert system does. Basically, it asks you the question, you define the problem, and then based on the answers that you give, it's going to look into its rule-based framework where you need to go. And the benefit of this is that we get an unbiased answer, because especially in engineering and in a lot of industries, people are very biased towards the things that they know. So I don't say that this is all innovative, our AI system, but because it's innovative because people don't think of all the solutions in that sense. Because it doesn't skip any steps, it takes you to this, not say tedious, but kind of tedious process of like answering until you have a final solution. And that final solution is not always the thing that you expect. So it's kind of like an unbiased route through your entire process that helps us design some downstream processes, choose a reactor, stuff like that, and give the best to our capabilities for an innovative process, because you get combinations of steps that you would never think of.
Yeah. So I think that's very interesting and also very different aspects of AI, which how I listen to that. Okay, it's called World Biomarkets. I mean, next year will be innovation, I understand, but this year is markets. So I mean, we are all very good in R&D. We have seen that throughout the whole conference. But actually, what everybody talks about is the missing market, or how complicated it is to get into the market. So how does all that influence markets and our go-to market? Anything where it helps?
I mean, I got three immediates for you, right? One is, if your R&D is faster and higher quality, your investment is much, much smaller, right? So in terms of getting to market, you get to market quicker, your investors are going to be a lot more delighted. Number two is, in the creation of data, in the way you communicate that data to your partners, you start to create dialogues around different value pockets that get created. Yeah, and so I love this idea of being able to enhance the value proposition. by being able to communicate your data to customers in a new and interesting way. So I think that's a different proposition as well. Also, maybe the way you capture their data to come into your data set to improve the overall learning is another interesting element to how value can get created. And then the third one is not just the value of your investment cost coming down, but then that opens up the number of targets you can be inspired to go after. And I mentioned that right back at the beginning, is if you can get value by chasing a target that had been considered previously unapproachable, right, that's a wonderful fishing ground to be throwing the line into.
Okay, great. Do you expect anything which it will help to go to market?
So I think the expected part is that you can accelerate the R&D process itself, right? But that's only a minor part of the whole
Is that
journey.
really the hindering part so far, that the R&D is too slow? Is that the thing which keeps us away from the market?
A lot of the market. Yeah,
Okay.
absolutely.
Sorry for interrupting.
No, it's fine. But then obviously all of us know that the next big thing is the scaling up, right?
Yeah.
I think our hypothesis is that if you know what type of equipment you use, and you know what is the impact of the equipment on the actual function or properties of your material, if you have enough data on that, and most companies do actually have enough data, then you can also model what is the impact of scaling up on your performance. So that's a new avenue that we would like to try. And with that, I believe that you can actually also accelerate the scale up.
Would that mean that your company gets more work or less work?
Yeah, exactly. Yeah. What Jan Haan describes is exactly what we're doing in our line of work. We indeed look into the right type of equipment that we need for the scale up, so that we don't do things twice, right? Because you want to scale up into the best possibility as possible, so the highest commercial scale that you, the end goal, let's say. And if you choose the right type of equipment for that, based on all the data that is being given by the customer in our case, but also what you can find online, and you have of course also databases that do a lot of experiments gathering data, so there's quite an extensive library of data available online, maybe not free, but it's available if you pay the price. So yeah, with that data we can design the equipment and then hopefully don't make mistakes. But also if you know what the end design of equipment is going to be, then you also know what kind of lab trials they need to test. So basically you cut down, again, R&D time, because they only do experiment in a specific subdomain, because they know which subdomain they need to investigate to be later on in the lowest manufacturing cost for their end product. So yeah, cutting down R&D costs is again the same recurring topic in this case.
But obviously it also leads to the question now, which is probably the key, the business models. So who will gain, so to say, these efficiency gains? Is it your company? Will your company disappear because everybody can do that? One question, I'll just pass on, then I'll let you talk. And for you, I mean, if you have now finally done the good data, great, then everybody else can use it as well. So is your work then kind of devalued and somebody else takes it? And for you the same, I mean, why can't not everybody else do the same work and be quick in R&D? So what is then, how will this impact your very specific business models?
Well, in our case, as Jan Harmer mentioned in the beginning, if you have a model and you put garbage in, you get garbage out. So you still need an expert behind the system to get the best possible outcome out of the system. Because you cannot just throw in everything and then expect an answer back. But also, we are aware, like ChatGPT, for example, it's a very fast developing software that could potentially replace some jobs, indeed. However, we are also working that in PDC, of course, that we want to incorporate ChatGPT into our own AI system, but not as a replacement, but as an aid to it, to get quicker response, a more faster setting, that you get your answers a bit faster without skipping any of the intermediate steps. Also, I read this funny article which has been published in March in Nature Chemistry, if I remember correctly, where they compared 8 large language models for the chemistry business, and they asked 2,500 questions to the large language models. And the highest percentage that was correct was 78% of the questions, meaning 20% is wrong. ChatGPT had 60% correct of the questions, meaning 40% is wrong. if you don't have, let's say, a qualified person behind that machine, you cannot distinguish between the wrong and the correct answers. So basically, the meaning, if you put a person over there that has no knowledge or not sufficient knowledge on the system, you get almost half of your answers is incorrect in that case.
But 1 year down the line, will it be the same, or in 2 years?
It's very difficult to say. It's learning fast. We are aware of it. Nowadays, I saw in ChatGPT the newest version that it also gives references. So it's not just making up references, but it's actually links to papers. So it's learning faster and faster. So that's good. But I think you still need a qualified person to assess what the outcome is of the AI program. And that's for the coming 5 to 10 years for sure gonna be the case.
So, and I assume, so that means you will be incorporating it and you don't see that your very business model is challenged at this point in time?
No, we need to adapt with, so we need to adapt our business model in such way that we accept it and go take it along in our business and strengthen our business with the help of this.
Then, Jan, I'm over to you. So how do you ensure that you get some value for making all the data correct now, which is then fed into it?
I think this is a very valid question for all of the companies around here. So I think what most of us realize more and more is that data is actually the golden egg. It would be, in that sense, not so wise to, as a business model, create data and then provide it for free. So that will always be a collaboration between different partners in the value chain, or let's say in a pre-competitive way, that companies and research institutes will work together to leverage the data. So in that sense, I think providing quality data is for the greater good, but for those that participate, I think I must say. I think what you said about the interaction with experts, I think we all call that human in the loop, and this is really, really important to prevent all kinds of hallucinations, what we talked about just before this panel. You need to be able to judge whether a model is hallucinating or whether this is actually something useful that's coming out of the model. Yeah. And so far, this is not happening.
It's a great cascade of answers, right? Starting with the user is important, and to moving in, there's value in the data set, which we absolutely agree with. You know, as Exozymes, we're a cell-free exozyme engineering company. We're not a computational company, right? There's computational power in what we do, but we're an enzyme, cell-free engineering company. And so companies might feel hindrances in creating data and then unlocking value from that data. We don't, because we know what enzymes need to do. And so that bit of inspiration helps empower the predictions that are being created for us. But each prediction, with the feedback we're able to provide, whether it be through reinforced learning or whether it be through sort of directed prompts, makes that system even more powerful. And the more you do them, the more valuable your data set becomes, as Jan Harm was explaining. So how do we capture the value? Like, we just keep getting better at these data sets, and then we keep predicting more valuable outcomes. Like, going beyond just creating a prediction for an enzyme that might be a little bit more thermostable, to creating a prediction for an enzyme cascade that could move a chemical moiety from this branch to that branch, and, you know, enabling pathways of those types of transformations and getting predictive power around that far down is incredible. Imagine getting predictive power then around the operational conditions in a bioreactor that's been scaled up, and how that could then feature back into the types of engineering work that we're doing. So this is a really, really exciting time, and I believe it will last us a good period as we learn to master not just immediately the tasks in front of us, but then how those tasks evolve and migrate towards commercial outcomes.
So maybe a little bit back to the little bit earlier discussion. So is it then a way to really close the gap to the traditional fossil way of acting? Is biotechnology specifically profiting from AI?
I mean, they're all tools in the toolbox, right? I mean, don't throw petroleum out because we believe it's universally bad. It still has an important role in society, and fermentation still plays a really, really important role in society. I think what we're looking for is what are the best ways of converting this substrate to this substrate to meet the needs of our customers or to solve the problems of the markets that we're serving. So we're imagining methods by which we can combine Exozymes approaches with fermentation-based. You might be able to use a ferm to produce an intermediate that we can then create an exozymes pathway to a final target. It could be that maybe that intermediate's coming from a fossil source, if that is so required for the supply chain that we're sitting into. Yeah, but I mean, it's understanding what the needs of the end market are and working backwards, I think allows us to find what's the right tool or the right toolbox to open up that answer.
Yeah, I was thinking more about, besides the fact that biotechnology obviously is very complicated, and as you describe it, to understand an enzyme is really tough, maybe tougher to understand a normal catalyst. And the other thing is time gap in developments. So while you had 50 years to ripen polyethylene plants, we didn't have yet the 50 years to get to the biotechnology perfection. So is that the way how to close the gap?
Oh, yeah, I mean, competing against fully depreciated assets that had a very, very long time to learn is not easy, but that's the nature of disruption. We wouldn't be up here if that challenge wasn't particularly suitable to our personalities. So yeah, get after it. But we can serve those end markets in a different way, right? That's always been the shtick with bio-based is we're going to use a different feedstock, we're going to use a different pathway, we're going to offer up a solution that couldn't be met by traditional chemistry. For us, enzymes act more like a catalyst, yes. We can target products that are perhaps a little different to what an organism would, yes. And we're finding our place in the world to accomplish that.
Excellent.
I think earlier today the PFAS replacements has been discussed shortly in the panel. And I think that's a beautiful example of where you can use AI, but stay away from the discussion whether this should be a bio-based, non-PFAS product or a petro-based, right? I think it can solve all kinds of issues, but in particular for bio-based, there are more than two pairs of eyes looking at the challenge at hand, and then not just sustainability but also safety is important. And I think with the tools that we have today, we can incorporate all that questions, let's say, that are on integrally and develop new products. And I think that is less so needed for petro, where we already have performance and cost, where we only need to look at safety, product safety. So in that sense, it makes sense to use these new tools for product development.
Yeah, well said.
Want to add anything? Or
Yeah, I actually agree with both of you guys, because it's not that you're going to replace one by the other, maybe in 50 years so, but currently that's not possible, because it's just too costly to do that. So you really need to find specific cases where you can apply the best application possible, either it is a petroleum or if it's bio. Like with the PFAS example, I don't think it's very cost efficient to add a bio replacement for that, but you can have petroleum replacements that are less dangerous for the human and the environment, basically. So it's very case dependent on where you're gonna add the solution. And it's all about what is the availability at that source, because if you have more bio feedstock available, but quite cheap at that specific location, then maybe a bio-based solution is more suitable. But if you're in a place where there's no biomass available or any other source, then you go petroleum.
I usually hate it if there's too much agreement on the panel, so I didn't work on that. I hope that ChatGPT will help us with the summary. No, okay, but we're already getting into our last round, so I would like to, some final say. Well, one thing I would really like to ask, also I'm asking not only for a friend, but for myself, how do you keep up with it? How do you manage to stay on top of it? Because it's obviously a question which probably everybody has, because every week there's something new. Maybe a quick round on that. How do you do that?
Well, I'm very interested in what's happening at this stage currently. So for me, it's also kind of a hobby to keep up with the new technological developments, and I like reading on it. I like investing time on it, even if it's outside working hours or not. I like what's going on, and it's a very exciting time to start working on this topic, I guess.
Is there a systematic way within TNO to keep up, or is it your personal engagement?
A bit of both, but in my team we are also developing a tool, also a large language model that actually extracts information from papers, and we basically have a tool now that can, let's say, download the data from those papers. So what we actually do is try to keep up with all the recent papers by just using that tool, providing us insights that we normally would take hours consuming. So that's one way. And often when I see a new paper, I ask my team, did we already incorporate that? And always the answer is yes. So they are more on top of it than me, which is good.
Quick answer, on the personal level, I step back from people who tell me why it can't be done, and I lean into people who tell me how it can be done. And that's why it's a real pleasure to be up here on stage with people that think as people who can do it.
Okay. It failed, actually. I'm sorry. Oh, I'm so sorry. It worked when I tried it. So unfortunately, we have to leave that out.
You had one job, Lars.
Now you have to hallucinate your summary.
Yeah, I cannot just make it up now. So, very interesting discussion with excellent people on stage, which did a really good job in keeping us up and giving us all the aspects of AI, from very, let's say, old systems which are now newly used to really new qualities of stuff. So I would like to thank you very much for being here. I think it's a topic which will be with us for the coming years. We can't help it, even if we didn't want to. Mm-hmm. But we've also seen that there's really big chances in it, and I think I could imagine that there's really some new qualities which could help this business to mature quicker and thereby maybe get into the market quicker. That would be my wish. With that, thank you very much for your attention as well, and thanks again to you. Thank you.
Thank you.